Hey guys, welcome to Deep Dive Coding. Today we solve LeeCode problem of the day, that is trapping rainwater 2 problem. So this is a hard problem. At the end of this video you will able to learn how to solve this problem effectively and why the solutions works properly. Now the solution is the problem is says that you have given a 2D matrix that will be this way, and this will give the height of the each wall, like each cell, and these cells have a few heights, and if you flow the infinite amount of water over this whole construction, and it will trap some water inside of that thing, and after the stabilized, you have to tell how much water volume it can trap. So if you look into the first example, this one, so over here these two cells and also these cells have trapped the water, and if you look into the second cell, like second example, it will trap water inside these cells. So you can say that at the boundary of this matrix it cannot trap the any water because it will flow over from this wall. So it only can trap water inside the boundary of the matrix. So let's take an example of simple example over here, that is 434, 412 and 444. So over here, if it can trap the water, so it will trap the water in this cell, on this one cell, like middle cell of this only, because it cannot trap the water at the boundary. So to trap the water middle cell, you have to think of this way, that there is a wall of 434, 24 and 444. These are the walls. It will construct a wall, and inside that wall it trap water. But how much water it can trap? The minimum of the wall height, that will be the 2. So over here minimum of all the walls, like all the cells will be, boundary cells will be the 2. So it can trap at the level of two levels of water. So in itself its height is 1, so it can trap one volume of water, so it will give the 2. So now how to calculate the trapped water volume? That will be the minimum of boundary minus current height. The minimum boundary will be the 2 and current height will be the 1. So it will trap one volume of the water. So if you think is carefully, like we have to track the minimum height. So if we start the processing from the minimum height and explore all the 4 directions, that will be the up, down and left and right, so we able to find that as it is minimum height, so it can trap at max of this much amount of height, and 1 is lesser than 2, so it will 2 minus 1, so it will trap at a minimum 2 minus 1, that will be 1 volume of water. Now I will take an help of the LeeCode exploration, that means this one, to explain the things properly. LeeCode exploration, this one. Okay, so these cells have, first of all we have to start from the boundary cell. We have to find the which is the minimum boundary cell, that will be the 7, and it will occur 2 times, this 7 and this 7. So if we start first this 7, so it have the like 4 directions, like 12 and 8 is the valid cell of up, down, left, right. Other one, like right and down cell, is not valid because it is outside of this matrix. So we consider these 2 cells, but as these 2 cells are already the matrix boundary, so we did not consider anything to add the volume of the water, because it will not contribute to the added the volume of water. Now if you look into this 7, so it have boundary 9, 8 and 8. These are the valid cells because right cells is not valid. And if you look into among these 9 and 8, these 9 and these 8 is the boundary of the matrix. We did not consider that thing because it will not save any water. And 8 is greater than 7, so it also does not contribute in the water volume. But if you consider these 8, so you have to look 4 direction. So above is 12, this is boundary value of the matrix, boundary cell of the matrix, and this 7 also boundary cell, but 10, this is not boundary cell, but you can consider this 10 as cell, valid cell, but 10 is greater than 8, so it did not trapped any water. But 2 is lesser than the 8, so it may trapped at max 8 level of water. That means 8 minus 2, that is 6 level of water, 6 level of volume of water it can trap this cell. And as this cell is trapped 8 minus 2, that will be 6, so its height will be 6. You can update this height will be 8, and it also can trap like 3 minus 8 minus 3, this also can trap the water. So I will show you these things. Like we have to track the minimum height of water. To do that we can effectively we can use the mean heap, and we insert all the boundary cell value in the mean heap and try to process each and every element from the mean heap, whichever is the minimum height. That means 7 over here. So similarly do the same things over here also. So it will process first 7, this 7, and it will also push this thing like 8 as in the priority queue. After that it will process this 7, and after this 7 is done, this will does not do anything. Already these cells are the pushed in the priority queue. So now it's take to the 8, because after the 7, 8 is the minimum. It will take these cells and push the 10 in the priority queue. After these things done, this 8 will be processed, but it does not insert anything or does not contribute any value in the answer. After that we are process these 8. As I discussed, these 2 will can level up to 8, so we fill this 6 level of water, so it will give the 6 as an answer to contribution and updated as value of 8. And instead of updating in the height map, we are updating in the priority queue only, so that we can effectively process further. After that it will process this one, and it will insert the 12 as in a priority queue. After this thing, this 8 will be processed, so 3 will also give the answer, 3 up to level 8. That means 8 minus 3, 5 also be contributed. And similarly these things are done. After these things done, okay, after all this process is done, any cells further process, it will does not give any answers or does not insert any cell in the priority queue, so it will give nothing to this, so it will all the green. Now let's try to code it so that you can able to understand properly. Over here the main concept is to track the minimum, start from the minimum. That will be the main concept. Okay, so we have to first define the directions of the 4 directions, valid directions. If you say that this is the current cell I comma j, so its top will be the I minus 1 j, right will be I j plus 1, and down will be the I plus 1 j, and left will be I j minus 1. So let's try to write the code. Okay, so direction of row, that will be the 4 size integer array, 0 0 my, okay, not 0 0, let's try for this way, that minus 1 0 0 1 0. That means we are taking first this one, this value minus 1, over here it's 0 plus, over here it's plus 1 plus, and over here also 0. And similarly direction of column would be 4. That means again we have to start similar same start point and end point, and similar way, that will be j plus 0, it will be 0, j plus 1, it will be plus 1, and j plus 0, this also 0, and j minus 1, that will be minus 1. Okay, so what we are doing over here, that we start, that will be neighbor row will be this way, like neighbor row, we current row plus d row of that direction, particular direction. And similarly neighbor of column will be calculated as current column plus direction of column and particular direction, and where direction is go 0 to 3, all the 4 direction. Now let's take a vector which is track whether it is visited cell or not. That will be the boolean element. Let's say you can say that visited, that will give, before moving ahead, let's try to define as number of rows equal to height map dot size, and number of columns equal to height map of 0 dot size. Row and column is separated, so we take number of rows, vector of boolean number of columns, and take all those are the unvisited, that means false. So after this thing is done, now take a priority queue. Okay, so priority queue, that will be the minute to process boundary cells in increasing order. That means take a priority queue. Okay, so priority queue of, it will element as cell. I will define the class cell, and you can name as boundary. And now let's try to insert the boundary of the matrix, that means first row, first column and last column. So let's add first and last column cells. So int I equal to 0, I less the number of rows, I plus plus. After this thing we have to push this thing in the priority queue. Boundary dot push, that will be push the elements of cell, that will be cell object, and that will take height map of I0 and I and 0. This will be the height, and after that we insert the row, and after that column. And you can take, I will define the cell object, cell class. So over here also cell height map of, this is the inserted for the first column, and after the last column, that will done by I num of columns -1 and I num of columns -1 for one column. Also we have to mark these things in visited array, so that will be I0 and equal to visited of I of num of columns -1 and mark as true. After these things done, now add first and last rows cells. So iterate through it. I equal 0, I less than num of columns, I plus plus. Now push these things in the priority queue, that will be the cell object, height map of 0 and I. After this thing 0 and I, first one is this 0th row and ith column, and it will be for the first row, and after that last row, that will be height map of number of rows -1 and I. This will do as number of rows -1 comma I. This is for the last row. After these things done, we have to mark visited similarly, so it will be 0I equal to visited of number of rows -1 of I equal to mark as true. After these two steps done, now try to proceed each and every element from the priority queue. Now we are doing until the priority queue empty, that you can say that not boundary, that will be the priority queue not empty. Until the priority queue is empty, we are proceeding each and element. So we have to take the element first by okay, so take element, top element, that will be the current cell, you can name as current cell, and this will be boundary dot top, and remove that element from the priority queue and boundary dot pop. So this current cell have the minimum height, that's why we find that is like it will always find a minimum height because we are using min heap. So we have to extract first the current row, you can say that current cell dot row, current column, that we can say that current cell dot column, and also minimum boundary, that is minimum boundary height. So it will be the current cell dot height. After these things done, we iterate through the each 4 valid directions, that you can say directions equal to 0, direction less than 4, and direction plus plus. Now neighbor row equal to current row, as I discussed over here, like neighbor row equal to current row plus d row of direction. That means current row plus d row of direction. This will be the neighbor row, and neighbor column will be current column. Okay, so current column plus d of column, direction of column, and particular direction. Now you have to check whether it is valid cell or not, like it should inside the boundary of the matrix. Is valid, I will define these functions as well. Okay, it will take n row, n column, that is neighbor row, neighbor column, and number of rows and number of columns. Also, if it is valid and if it is not visited, that means not visited of n row and n column. If it is not visited, we can proceed further. That means first of all we have to extract the height of this thing, like n height equal to height map of n row, n column. You will get the neighbor height, and if this neighbor height is less than minimum boundary, that means the current height we are processing. If it is less than, then it will contribute to the answer. So before adding these things, we have to take a variable of it. So int total water, this will take the total amount of water it can trap. So it will, we add over here, plus equal to minimum boundary minus n height, that is neighbor height. And after these things done, and we have to push this element because it is not visited yet, push this element in a boundary, that is that will be the priority queue, and we have to push this thing and maximum. We have to update the height as well. What the height will be, the maximum of neighbor height and minimum boundary. This will be the new height. After this thing, we have to give the n row as row and n column as column, n row and n column. Okay, and after these things done, we have to mark visited also, n row, n column, mark as true. At last, we have to return the total amount of water, that will be total water. This will be the total water. Okay, after these things done, we have to define the cell class, and another thing is valid function. Okay, I will define over here only. So let's try a private, although it is by default private if we do not specify it. So let's take a class of cell, that will be take of, let's public into row, column, and height. These are the 3 elements. it will take. And let's try to define the constructor of it. That will be the row, not row. First it will take height, because we defined below height will take first, and int row, int column. And let's try to save this thing also, and row of row and column of column. After these things done, and you will get you do not write anything over here, so you can just do it this way. After these things done, we have to define the valid function, like bool each valid. This will take row, that will neighbor column, and number of rows, number of columns. So we return whether it is valid or not. So row greater than equal to 0 and column greater than equal to 0 and row less than num of rows and column less than num of columns. So if all these conditions are true, that means it's a valid cell, so we can move forward. And apart from that, we have to define also one thing for the main heap priority queue, that we have to overload a operator, as we are saving the object in the priority queue. So operator less than will be overloaded, that will be the const cell ampersand other. You can, this is the constant method. So, and we have to return height greater than equal to other dot gst height. So it will simply do the ordering. That means whenever we insert the element in the minimum in the priority queue, it will always top element will be the minimum height, and similarly it will arrange it. Now let's try to run the sample test case. Okay, so over here I have some mistakes. I will discuss the time complexity of it. Now it's accepted for the, it's run for the sample test case. Now try to submit this code, and after that I will discuss the time and space complexity of it. So yeah, it's accepted. Now let's try to do the time complexity. So if you guys look carefully, like we are taking the priority queue, and each state, like each state in the matrix, we are pushing that state and popping that state. So you can say that min heap push and pop operation takes big of log n time. So each state, that means total states will be the row into column, total rows into total columns, and for each state we are iterating each state and pushing and popping each state only one time. So it will take time complexity of row into column and log of row into column. And space complexity, at the worst scenario, we push all the states, that means row into column, number of states in the priority queue, so it will take big of row into column. Apart from that, also we are taking the visited array, that also the row into column size. So you can effectively say that extra space will take big of row into column. As the over here you can say that m into n is given as 200, so at max, that row max would be 200, as well as column max would be 200. So row into column would be how much? So row max into column max would be 200 into 200, that you can say 400. Okay, that will, you can say 4 into 1e4. this much row into column, and also log of this one is also smaller than that, and so it will be under the limit. So yeah, thank you guys, thank you for watching, stay tuned for more videos.